People paid money for this.
Okay, welcome everybody. My name is John Coop. I was doing a demo outside, so some of you may have seen me already. I'm going to give you a quick overview of VPN and the Pi. I first became interested in this because there was a BBC article on it, on the tech articles, which if you're interested, drop me an email and I'll give you the link to it. It's in the slides as well. I own a company that we're using or selling a product with the Pi already, and we're looking to do more. And one of the things that is quite useful to us is having application programs that are secure, so you can access a program from a remote site and not have anybody spy on what you're doing with packet sniffing and so forth. So I was quite interested in this. Detailed instructions, I'm not going to do all that, it's just 20 minutes of boredom. But if you can have a go yourself, I can send you the link if you're interested, or write it down yourself. In the instructions, it talks about using Change IP, which Change IP, when I try to use it, seems to be completely down. The website's there, but you register and nothing ever comes back. So I use DNS instead. And the article by the Read Write people, which is quite a good article, doesn't cover dynamic IP addresses at all. If you're wondering what all these terms mean, I will be covering them shortly, but those are just some header notes. Everybody's got a rough idea about Linux and stuff like that, because we are going to be... Okay, good. Okay, so the idea is we were going to use the Pi to set it up to be contactable from the outside world rather than the Pi initiating the connection. So think about the way your home router is at home. You normally initiate a contact out to the BBC website, to somebody else. So there are two different sections. There's the outside world, and then behind your router is where you are, and you have that makes life a bit hard if we're looking to get into our private network. Okay, and particularly it's hard because often, because there's a shortage of IP addresses, which we'll mention in a moment, our IP addresses change, so we're not quite sure who we want to contact. So DNS, Domain Name Service System, converts a name to an IP address. So when we want to talk to the BBC, if we do an NS lookup on www.bbc.co.uk, we get back an IP address. Now the BBC's ones, they don't change. Yeah, they're fixed. But we've got our little home router sitting at home and we're on Blue Yonder or whatever. Our IP addresses change. There are two types of IP addressing. There's version 6 and version 4. I'm not going to consider version 6 because I don't know it. There's one good reason. So we're not going to consider it. Most of what you see out there is IP version 4. But I don't know if everybody was aware that the world is running out of version 4 addresses. Oh good, I've got some nods. Of course we do, John. Okay, so what happens is they tend to be allocated as needed. And when we're sitting at home, we have one IP address that we're known, that we can be contacted from on the internet. That's the IP address of our router. And then we have bunches of IP addresses for all the devices we've got plugged in. So my smartphone, my Raspberry Pi, my laptop, etc. So we've got internal ones. The internal ones, you can normally tell which ones they are because they begin something like 192 or 10. Begin 192 or 10, they are typically internal IP addresses. So a nice diagram that I stole from somebody else that I found on the web. Suit my purposes admirably. So you can see there, the router has an external IP address of 216.13.154.34. And then inside, one of those things could be our Raspberry Pi, we'll have 192.168.0. something. Now the .com is nearly always reserved for the router itself. Okay, so you can connect to the router using typically there's a web server on there, and you can use that for configuring your router. So, when something comes in and we want it to connect to us, so we've got our, maybe it's just a simple website. When somebody wants to come into us, we have a slight problem because the router, we have something coming on port 80 or 443. The router doesn't know where to send it to. Which box that you've got connections to the router do you want this this stuff to go to? So we make a request. The router doesn't know where to send it. It's easy enough when we're going out. We just say we want to go to port 80 on the BBC's website. No problem. But when it's the other way around, we have to do something called port forwarding. So that's what we need to do, and it's relatively easy to set up on routers, but every router is different. So I can't really show. If I could show you what it is for my home router, but it's a bit. It's going to be different for you. Port forwarding. What it means is when something arrives on a specific port at the router, it will then be sent to a specific internal IP address. So it's going to go to a fixed IP address, and that's what we're going to need to do. Set up our router so that something arriving on a specific port is going to our Raspberry Pi. So the Raspberry Pi then will take that data and then can use it to communicate to the Raspberry Pi. Well, more about this static IP versus dynamic IP addresses. Typically then, neither the external IP address on you can pay extra to have a static fixed IP address, but I'm very mean, I won't pay for it. So if you just use .dns, it's free. Nor even the internal IP address of the Pi that's connected to your router is necessarily fixed. Normally your router can be set up to make it fixed. Obviously setting up of an internal fixed IP address costs you nothing. So you may see reference to a company called DIN-DNS as well, and that was taken from the abbreviations Dynamic DNS. Unfortunately, they charge now. As I said, I'm very mean, I won't pay anything. So I don't use DIN-DNS, I use DuckDNS instead. What it does, it basically translates the name that you give it. You contact DIN-DNS or DuckDNS, and it will convert the name that you're asking for to an IP address. The one I'm using, there's this WebHR, that's the one I constructed, and you can have your own name, so I chose one, WebHR. And if you do an NS lookup on webhr.dns.org, it'll come back with the IP address of my router at home. Ping this address on different days and you'll get a different address. And what it does, the way it all works is a script runs every few minutes on the Pi that contacts DuckDNS, and then DuckDNS checks to see what IP address sent the message. So there's like a security string that identifies who I am, talks to DuckDNS, says here I am. DuckDNS then looks up to see what IP address it came from, and then anybody else trying to talk to webhr.duckdns.org will get sent to the correct IP address. Some things you might want to try. I got the slide, unfortunately, is much too small, but never mind. On the left-hand side, you'll see Google, and if you type into Google, what is my IP address, it'll tell you your external IP address. It'll tell you. And so if you think to yourself, well, maybe my IP address doesn't change, try it. You might be surprised. Top there, you can't see it, but there's my, I've got my IPv4 address of my Windows box, which is 192.168.0.8, but it's just an address that's been configured by the router. And on my Raspberry Pi, I did a host9 -L, and that's also giving me the IP address, and that's a connection using the Cygwin to my Raspberry Pi, and I can see it's 192.168.0.2, and then the bottom one is pinging webhr.duckdns.org, should have made these a lot bigger, and it's indeed coming back as the same as what is my IP address from Google has given me. So 94.174.12.208, that's all that slide is showing. Next time make those a bit bigger, John. Excuse me. So what is VPN? Well, it allows us to sit anywhere in the world and use our internal network as if we were local to this internal network. No one but those authorized can access the network, so all our data is secure. How do we achieve this? Well, we use keys. And we have a secret decryption key, which we keep ourselves, that's what we call our private key, and then we have a public encryption key. So what happens is, somebody from outside can send us a message and they can encrypt it, but only we can decrypt it. If anybody wants to ask any questions, please feel free.
What about the NSA? Can they decrypt it?
Oh, good question.
GCHQ?
Yeah, quite possibly. I don't know enough of their secrets. Sorry.
With their quantum computer.
They know yours.
Yeah, for sure. They aren't going to find very interesting stuff, are they? That's for sure.
They could just use a $5 wrench.
Yeah. Yeah, just break the door down, yeah. I thought we'd take a look at a simple example of encrypted data, but something we're probably all quite familiar with. And I also wish I brought some water in, never mind. HTTPS, you know, when you connect to your bank and do online computing. And sometimes called the secure socket layer, was invented by Netscape to ensure secure transactions between the web servers and browsers. So that's where it came from. It uses this concept of a certification authority. So when you connect to a website, one of the dangers is that maybe that website's down or something and somebody else is pretending to be that website. Do you know that the website you're connecting to is who they say they are? And this concept of a certifying authority allows you to get up to one of these major companies that guarantee that you're talking to who you think you are. So that the certificate is examined to check that that's true. And you'll get a warning if that's not the case, if the certificate doesn't match your website. You may have seen it. It's, as I go on the next slide, if it's on a non-public network, frequently this checking of the certifying authority is ignored because there's not much point at all internal anyway. So, and you'll see those warnings. So let's go through the flow. So a browser requests a secure page, typically HTTPS. The web server sends its public key with a certificate. So that's the public key that's used for encryption. So we send that out to the person person that's asked for a web page, an HTTPS web page. Browser then checks that that certificate was issued by a... Oh, thank you. You're very kind.
5 minutes away.
Oh, only 5 minutes away? Wow.
I know.
You have fun when you're enjoying yourself. Thanks. Browser then uses that public key to encrypt a random symmetric encryption key. So your browser sends that back a key, and then the web server then decrypts it with its private key. So I'm into rush now. The web server sends back the requested HTML document and the encrypted data with the symmetric key that the browser sent out. And then it's displayed for you. Differences between HTTPS and VPN is all very similar. although we're not tied to HTML data. Key has to be installed at the client. They're not delivered as part of, and it goes in these profile files. The profile files used can be password protected. So I've got slides showing it in a second. Okay, there's an example of a VPN, OpenVPN, and it's OpenVPN that typically the Raspberry Pi uses, and that's the sort of thing you've got in there. You've got your certificates and keys in there, and a number of configuration things. That 1194 is the port that we have on the Raspberry Pi. You can configure your own different one, where the data is going to come into. And we're also seeing Proto-UDP because it's using UDP rather than TCP. OpenVPN is free, but when you install it, allow a day. And I read that first time, I thought that can't be true, but it's true. It takes a day. Google are moving away from 1024-bit keys, and if you want to go to 2048-bit keys, it took 3 hours, approximately 3 hours for it to generate a key. It takes a long time. It's not 3 minutes, 3 seconds. This is 3 hours. So if you're thinking I'm going to mass produce these things, forget it. Ain't going to happen. On each client, you'll need the OpenVPN client, a profile that you generated. That takes time as well. And I thought, just to finish off, what can be used for? So accessing files in a remote office, running internet web programs at remote location, because you really are secure. You have to be actually on that local internet or on that VPN before so you can use HTTP within that internet site. Securing voice over IP. Hiding your real location. BBC checks where you are in the world. Yeah. Although the example that you get wouldn't work because you need to have all your data, all your web, all your requests going through the VPN, whereas the default for the OpenVPN client is just data going to your internal network. So you need to do more work. Okay. And there's a link there for using VPNs for hiding your real location. I've got some slides, good job, to show OpenVPN on my Android phone. You can get VPN clients on some routers, make it easier to use devices not supported by OpenVPN, but Raspberry Pi does. So here's my snapshot from my mobile phone. It's this phone in my pocket. So there's the OpenVPN Connect. You have to copy across your OpenVPN profile that you've generated on your Raspberry Pi, which contains keys and details of where to connect to. I copied the files, the OpenVPN stuff, because if you give that away, it's dangerous to somebody else. So you need to get it on there securely. Only one of these VPN profiles can be used at any one time. You can typically you can password protect it. I bet you can store the password on your phone. So here it is, we're up and running. I've tapped my password in and got it to save it, do connect. And then it connects. Hopefully, I've tried it in Spain, worked. And then I used ES File Explorer, which is an Android app, and I can then access my Pi, the Pi that's actually running the VPN client, running the VPN server, and also look at the Windows box, this Windows box, which is at home. So open up ES File Explorer. There's some Windows files on this box being viewed over my Android phone. Not in the same room, obviously, somewhere else. And there's some Raspberry Pi files. That's the root directory. I've accessed the web server on my router. Remember we mentioned the router has its own web site for you configuring, and there's an example of the website for my router being accessed over the internet to my Android phone. Just used to prove the point that you can have web servers running over this. Okay, last slide, other uses for keys, SSH, for NSCP and SFTP. You can use it for not being prompted with a password, which is really useful if you want to do scripting on a remote box. So by making use of public and private keys, you can access. So do I see a question coming? No? Okay. So you can access scripts to be triggered from another computer. Okay, that's it. How was that pretty much on time?
Absolutely fine. Absolutely.
Brilliant. Okay. Anybody got any questions then? Please.
Do you have to enable IP forwarding on the Pi to get it to be able to access other devices on the network, or is that part of the open VPN setup?
I think I had to open. I think I did.
Yeah.
I haven't got the detailed instructions in front of me, but I just laboriously followed the instructions, and believe me, laborious is the right word. Yeah, I think I did. Yeah, you just follow step by step and allow a long time.
Was that Pi 1 or Pi 2?
It was Pi 2. All I've done the Pi 2, and it's still at home and it is connected.
So the Pi 2 still took 3 hours to generate that key?
Yes.
Right, yeah.
That was 2048 bits. If you go for the 1024, it's done in a matter of minutes. But Google, and I was going to put the original for that slide said, and the instructions say this is being paranoid to have 2048, but now Google have specifically said they are going away from 1024 and going to 2048. So.
Well, the thing is that if you can do 1024 thing on the Pi in a couple of minutes,
Yeah.
the NSA have got better computers than you.
So that.
The NSA have got better computers.
Oh, absolutely. That's what occurred to me as well. That's what
The reason is that it's making it computationally expensive to break
Yeah,
these brute force.
absolutely. Any more questions or points? No?
Thank you very much.
Okay.